Good day, everyone. So for this lecture video, I'm going to discuss the answers for Mach 4 chemistry. So let's begin. Number one, the question is, when calcium chloride is added to water, the container becomes warm. Which statement best describes the process? Letter A, the process is endothermic because the solution absorbs heat. Letter B, the process is exothermic because heat is released. Letter C, the process is endothermic because the temperature rises. And letter D, the process is neither endothermic nor exothermic. So before we um, answer this question, we have to look back on the definition of endothermic and exothermic reaction. So when you say endothermic reactions, these are reactions where heat is absorbed. While when you say exothermic reactions, these are reactions where heat is released. Now, we could, if we're going to look at the question, if we're going to look at the situation, it was mentioned that calcium chloride was added to water and the container becomes warm. So we're being asked which statement best describes the process. So for some students, they get a little bit confused because they feel like, oh, the container feels warm, so it must have absorbed heat, right? But that's not the case. So when we talk about endothermic and exothermic reaction, we have to look at the system and the surroundings. So when we say endothermic reaction, heat is absorbed by the system. And the same goes for exothermic reaction. So heat is released by the system. Now, in this situation, we have to look at what are we actually observing when we talk about the dissolution of calcium chloride. And if you're going to touch the container becomes warm. Now, in this case, the system actually, in this particular situation, is the calcium chloride particles. Basically, we're just looking at, we're not really looking at, but we are defining calcium chloride as the system in this particular process, and water plus the container is actually the surrounding. So the reason why the surrounding feels warm is because the system releases heat and that heat is absorbed by the surrounding, therefore causing the increase in temperature of the surrounding. So in this case, the system releases heat to the surrounding. And because the system releases heat to the surrounding, then that means that the entire process is classified as, or is best described as exothermic. Okay? So, for example, when you burn fuel, when you burn wood, for example, so it would produce flame, it would produce fire, and then the surrounding air would feel warm. So in that particular case, the system is actually the burning of wood or the burning of fuel. And then it would release heat, and then the air around the fire would feel hot. So they're actually part of the surrounding. What you're actually observing was the increase in the temperature of the surrounding rather than the system. So that's why we could classify it as exothermic. The process is exothermic. Okay. So yeah, basically we're looking at the surrounding. So we're talking about the water here and the container. So a rise in temperature of the surrounding indicates that the process releases heat. Therefore, the dissolution is exothermic. So yeah, so when you say exothermic, you have these reactions. These are reactions where or processes where heat is released from the system to the surrounding, while endothermic reaction, it's the other way around. So heat is absorbed from the surrounding to the system. Uh, we could, if we're going to observe the surrounding for exothermic reaction, the temperature of the surrounding increases because the flow of heat is from the system to the surrounding. While if we're going to measure the temperature of the surrounding in an endothermic process, it would decrease because the flow of heat is from the surrounding towards the system. So there's a decrease in heat from the by the surrounding, so the temperature would decrease. Uh, yeah, so basically that would explain the why the answer is letter B from the question. Okay. So moving forward, number 2, what is the empirical formula of a compound with molecular formula C6H14N2? So when we say empirical formula, it's actually the smallest whole number or smallest whole number ratio of each of the element in a compound. So if we're going to look at the chemical or the molecular formula, it's a C6H14N2. So if we're going to look at if we want to know the ratio of the number of carbon, hydrogen, nitrogen, we have to divide each of the subscript by the greatest common denominator, which in this case is 2. So greatest common denominator for this numbers 614 2 would be equal to 2. So just divide everything by 2. So you will get C3H7N, which is letter A. So when we say, again, empirical formula, this is uh, the largest whole number ratio of the elements in a compound. While when we say molecular formula, molecular formula is the actual number of atoms of each element in a compound. So empirical formula is the ratio, largest whole number ratio, while molecular formula is the actual number of atoms. So for this particular compound, in summary, the number of carbon would be 6, the number of hydrogen would be 14, and the number of nitrogen would be 2. While if we're going to look at the ratio for each of the elements, carbon to hydrogen to nitrogen, the ratio would be 3:7:1. Number 3, which pair of elements is most likely to form an ionic compound? So we have letter A, carbon and oxygen. Letter B, nitrogen and hydrogen. Letter C, calcium and fluorine. And letter D, sulfur and oxygen. So if we're going to look at the options, I think one of the main or something that would we could say different from the rest would be um, letter C, right? Because only letter C contains metal, in this case calcium. So, which fair enough would be which makes sense actually because ionic compounds, especially for binary, we're talking about pair of elements, right? So we're talking about binary compounds, meaning you have two elements. These are compounds with two elements. So um if we have a binary if we're talking about binary compounds and the elements involved are a metal and non-metal, then so for binary compounds, uh, ionic is usually formed between a metal and nonmetal, while covalent forms between two nonmetal. So in this case, the only option where there is a metal as one of the element would be letter C. So in this case, the metal is calcium. So ionic compounds usually form between metal and nonmetal. So calcium is a metal while fluorine is a nonmetal. The rest, so carbon, oxygen, nitrogen, hydrogen, fluorine, sulfur, and oxygen, they're all nonmetals. Number 4, a solution contains the maximum amount of dissolved sugar at a given temperature, but no undissolved sugar is present. So the solution is, so since we're talking about the maximum amount of dissolved solute in a particular temperature, then that solution can be described as saturated solution. That's precisely the definition of a saturated solution. So that solution is holding the maximum amount of solute at a particular temperature. So a saturated solution contains the maximum amount of solute that can be dissolved at a particular temperature. Undissolved solid does not have to be present, but addition of more solid will not dissolve more any more solid when the solution is already saturated. So, for example, of course, the previous question is about sugar, but say, for example, we have salt, sodium chloride. So, for sodium chloride, the maximum amount of, if you have 100 grams of water and the temperature is kept at 25 degrees Celsius, the maximum amount of sodium chloride that we can dissolve or that can be dissolved is 36 grams. So if you add 36 grams of sodium chloride in 100 grams of water at 25 degrees Celsius, then that particular solution is a saturated solution. On the other hand, given that we have the same setup, so water as solvent, 100 grams of water, and then we have sodium chloride. If we only add 10 grams of sodium chloride, then it's below the maximum amount that can be dissolved. So that means that the um, the solution is unsaturated. On the other hand, if you're able to dissolve more than 36 grams, so how do you do that? Basically, what we do is we elevate the temperature. Sodium for at least for sodium chloride, increasing the temperature would result in an increase in the solubility. So probably the capacity would increase to 40 or 50 at higher temperature. 40 grams or 50 grams of sodium chloride at higher temperature. So uh, if say for we added if you add 40 grams of sodium chloride and then elevate the temperature, let everything dissolve and then cool the solution very slowly back to 25 degrees Celsius, then um, all the 40 grams would remain dissolved. So that means we have a supersaturated solution. Now, dilute solution is a bit more of a, we could say, relative comparison, especially when we talk about concentration. So, dilute solution contains small amount of solute, and if we're going to say determine the actual concentration, we could say that the concentration is very low for dilute solution. Okay. Number 5, which substance exhibits only London dispersion forces between its molecules? So you have letter A, water, letter B, ammonia, letter C, HBr, and letter D, Br2. So we actually have, at least for covalent compounds, we have uh, three major intermolecular force of attraction, or we could classify them based, or at least we could describe the strongest uh, intermolecular force that a particular covalent compound could exhibit. uh, we could classify them into three, right? So we have the hydrogen bond or H bonding. We have dipole-dipole, and we have London uh, dispersion. Now, among the three types of intermolecular forces, the easiest to identify would be hydrogen bonding. So, what you need to look out for is a hydrogen bonded to either nitrogen, oxygen, or fluorine. So in this case, for example, if you look at water, water, you have hydrogen bonded to oxygen. So that means water is not the answer. Most likely, water is hydrogen bonding. Ammonia, likewise, has a hydrogen bonded to nitrogen. So we cannot answer ammonia as well because the primary intermolecular force of attraction between ammonia molecules would be hydrogen bond as well. So now we're down to two. We have HBr and Br2. Now, one thing or the one of the criteria when it comes to dipole-dipole is that you have two um, elements with high En difference, and number two, they're not symmetrical. For London dispersion, these molecules are polar basically, while for London dispersion, the molecules are generally non-polar. So you have two elements with low electronegativity difference, or this the entire thing is symmetrical. Uh, Based on this, we could actually have an answer already. So if you look at HBr, bromine is a bit electronegative. So the difference between hydrogen and bromine is relatively high compared to bromine. So just look at this. Just look at this option, letter D. You have two bromine atoms. The En difference between two bromine atoms would be zero. That's very low. So right away, you could say that the molecule is nonpolar. And at the same time, if we're going to look at the geometry of these two bromine atoms, the it's symmetrical. So right away, we could say that letter D is actually non-polar. So it's the substance that would exhibit London dispersion forces only. Okay, so as I mentioned a while ago, hydrogen bonding is these are it's actually the strongest among the three um, mentioned intermolecular force of attraction. So, for example, is water. Water can exhibit hydrogen bonding, and it's usually exhibited by substances where you have hydrogen bonded to very electronegative elements such as nitrogen, oxygen, and fluorine. Dipole-dipole is the attraction between the partial positive and negative ends of polar molecules. So in this case, for HCl, the hydrogen is partially positive, and chlorine, being an electronegative atom, is partially negative. London dispersion forces are weak attractions caused by temporary fluctuations in electron distribution. So basically, because there's it's there. If the molecule is nonpolar, there's no polar positive, partial negative, and then it's just it could only like create temporary dipoles or induced dipoles, which would cause the attraction, but these attractions are very weak. Number 6.